In this tutorial we're looking at the process of combustion, a chemical process, and through this process carbon is being added to the atmosphere. Combustion is simply known as burning, and we burn stuff. The stuff that we burn we'd call fuel, and to burn that fuel we need oxygen. So that makes combustion an oxidation reaction. So here are raw materials, fuel and oxygen, and they're going to produce the following products: carbon dioxide and water. There's also energy conversions taking place, so the chemical energy stored in the fuel is going to be released in this bonfire we see here. There's light energy and enormous amounts of heat energy. If we move from the word equation down to the chemical equation, we get some extra information here. We've got a molecule of glucose. It's got 6 carbon atoms in that molecule of glucose, and we're getting still our 6 carbon atoms in carbon dioxide. So the mass stays the same, that important law, conservation of mass. So what we have on the left hand side we also have on the right hand side. We saw this slide earlier in the carbon tutorial, and we've got reactants and raw materials on the left hand side, products on the right hand side. So what we can see going on here is that one atom of carbon in methane is basically being modified somewhat. So instead of the carbon atom having hydrogen atoms attached to it, it's got a couple of oxygen atoms attached to it here. So we've gone from a molecule of methane to a molecule of carbon dioxide, with water being produced too. So the carbon dioxide gas is being added to the atmosphere. These are some photographs I took in Antarctica, and it just shows you how much we rely on hydrocarbons. So when we were out in the field, when we were out in Taylor Valley, we took with us diesel, and that was used to power the electrical generator, and we might use that electricity for our lab equipment, but also to heat the jug so we can have a hot drink, and for the sandwich toaster as well. In our tent, where we spent quite a bit of time working and processing our samples that we'd taken, we've got here our diesel heater. So basically that would be left on, that'd be pumping out plenty of heat energy for us so we could stay warm in the really cold environment. We weren't always at base camp. Sometimes we had to move out and take samples elsewhere, so we would take with us a very simple sort of cooking device here, our primer stove, no different to a primer stove you'd use in New Zealand, and this runs with a mixture of white gas. Cooking at base camp, we'd use a standard gas cooker here, this time using propane gas as the fuel. For using our vehicles, I noticed that we used what was called MO gas, which is a petrol equivalent, and that would be used to fill vehicles such as the Hagland, specially designed and adapted to work in the snow. So you can see how dependent we are on these hydrocarbons in Antarctica too. It doesn't feel good to go down to Antarctica and burn fossil fuels in this pristine environment, and of course we want to try and protect the environment, and there are ways that we can do this and are doing this. We want to keep our carbon footprint as small as possible. So in Ross Island here we can see that the Kiwis have built this fantastic wee wind farm. So we've got 3 turbines here, and with Antarctica being the windiest continent in the world, there's plenty of wind energy that we can harness to actually provide some electricity for us. So we're doing what we can to try and limit our carbon footprint in Antarctica. been calculated that the amount of energy that the turbines produce cut the diesel requirements by nearly 500,000 litres, which is quite incredible. And these turbines don't just generate electricity for Scott Base, but electricity is taken down some 3 kilometres away to McMurdo Sound. McMurdo Base is where the Americans are based in the Ross dependency. There's a couple of there's a webcam link here for you, so you can see these wind turbines in action and learn a little bit more about sustainability measures in Antarctica. Okay, so that's combustion covered.